We are on Lecture 5. We're going to start talking about Python functions today. So the reason we want to talk about functions is functions are a nice way to encapsulate different things you want to do in your computer. So, if you've ever written a lot of code, if you've written code, you know that if you have to do the same thing more than once, what you end up with is you end up duplicating code 3, 4, 5, 6, 37 times, whatever. And that's painful for a number of reasons. One, you had to write it all. Two, is it exactly the same code or not exactly the same code? If you have large, complicated code blocks, it can be hard to see whether the code is exactly the same or whether there's some subtle differences. So what we want you to do is we want you to get out of the habit of duplicating code and instead start running functions where you have that functionality encapsulated. And then if every time you do something the same, you call the same function, well, then you know that that code is the same because it's executing the same block. And if you're calling another function, well, hopefully that function is described so that you know whether, so you know what it does as well. And if you have these multiple copies, code degrades over time. Not that code gets wrong, but what you expect the code to do degrades over time. So even if you have written perfect code, and that's rarely, if ever, the case, that code is perfect for any sufficiently complex piece of code. There's always errors in it, and errors that need to be fixed. But let's say that you've written the perfect code and 2 years have passed, and all of a sudden the users are expecting something else, or you're running on a different piece of hardware, or you've added another course, or you've added another department to the school of science, right? Your code has to be able to be modified, and if you have these multiple blocks all over the place, that means you have to modify it multiple times, and you have to remember to get all of the times that it has to be modified. So what we want you to do is we want you to start thinking about encapsulating code into a single unified block called a function. You can test the function thoroughly. You don't have to test the function 9,000 different times. You can test it once thoroughly, then call it every time you need to replicate that functionality. The motto we want you to remember is don't repeat yourself. Define the code once and then use it multiple times. And this is also going to help you when you're writing complex programs, because if you get in the habit of thinking about these small functions, you can use these small functions kind of like Legos, right? If you've ever worked with Legos or with a construction set, you build little pieces and then you attach them together to get even bigger pieces. So lines of code are the smallest things. Maybe a wall is the next biggest thing, and you can start using this to kind of build up more and more complicated structures. So with code, that allows you to think of things at an appropriate level of detail, and allows you to do a better job with your design and with understanding and writing code that's understandable. We want you to remember this programmer's motto, dry, don't repeat yourself. I've got a better one. I like to say good programmers are lazy. We're not lazy in that we don't do a good job. We're not lazy in that we don't test. We're not lazy in that we don't do a thorough design. But we're lazy in that we like to do things once, do it right once, and then move on to the next thing. And that's this whole idea of functions allow us to do that. So let's take a look at what a function actually is. So we'll start off with this length function. We've done this length function a couple of times. So let me pop over here to a good old spider, right? We execute length of RPI puckman, and we get the value of 11. So this length is a function, and a function takes one or more arguments. So in this example, the argument is RPI puckman. It computes a new value, a string or number, or maybe it does a print, provides information back. So it has something that it actually does, and then it returns a value that can be used in another part of the program or for later. So we can do something like A equals length of RPI puckman, and now we've assigned the variable A the value 11. And for length, this is the argument. The string RPI puckman, this specific argument. We can change the argument as we go along, call it with multiple different arguments. Right? What it does, the actual function it provides, is it goes through a string and it counts how many characters are in the string. And the return value is the value of the number of characters it actually counted. And these functions are, really pretty much the same as mathematical functions. So coming back here, right, we have this whole concept of a mathematical function. In this case, we have the function. Well, let me kill this. Well, just let me start a new one. We have this concept of a mathematical function, and I'll put it in a comment block. Function a of r, right, is equal to pi times r squared, right? And this function is for the area of a circle. And we can take this and we can translate this into a function in Python, right? So we're going to take a mathematical function and we'll convert it into a function in Python. Function in Python always starts with the 3 characters DEF for definition. We follow that by the name of the function, right? So our mathematical function is named A. Our Python function is going to be named area circle. And then we give it the parameter. So just like in here, we have one parameter r. For our function, our area circle function, we are going to have the parameter radius. And this pretty much defines this part of our mathematical function. To cap this off, we're going to put a colon at the end for the Python function as part of the Python syntax. And after that, we enter the body of the function. You'll notice that we're kind of tabbed in or spaced in about 4 spaces. That's how we indicate we're in the function. We go into a different level of indent. In this case, we're going to go in 4 spaces. And now we can start writing what we want the function to be. Well, our mathematical function uses pi. We need to know what pi is, so we're going to create a local variable pi, make it easy to 3.14159. I don't want to do anything else. Right? So that's a floating point value. We want to calculate the area. We want the area to be pi times our radius squared. Right? And then the length function returns the number of characters in a string. Our area circle function is going to return the area we calculated. Okay, and at this point, that is, essentially the Python version of this mathematical function. If we want to continue on and now we want to use our function, we can come down here and we can, write additional code. So we can say A equals area circle, and we can give it a value of 1. Right? And then maybe we want to come down and we want to print A. And I'm going to take, and we can do this multiple times. So just like with this function, this mathematical function, if we have the definition of the mathematical function, we can calculate the function for multiple different arguments, multiple different values of radius, just by calling, A sub 1, A of 1, maybe we want to do A of 2. And notice that we're picking values, these first 2 values, right? A of 1 should be identically back at pi. A of 2 should be 4 times pi. So we know that's going to be around, 12.5, let's say. And then after that, maybe we want to do our real calculation. So we've done some testing. Maybe we want to do A of 75.1. And I'm going to actually steal this code from here just so I don't have to type in all of this. But what I want you to see here is that we're calling the circle function 3 different ways and with 3 different values of the radius. Right? So we call the area of a circle with argument value 1 first. We put the area into this variable a, and then we print out, just a. Or maybe we want to come in here and we want to say a circle with radius of 2. We want to use our format to format the area nicely to 2 decimal places. But in order to complete this, we have to call our area of circle with the radius 2 from within our format statement. Or maybe we want to come in here and we want to define a local or a variable r in our global frame, and then we want to call the area of circle with r and put it again into our variable a, overwriting any previous value, and then print out both r and a using our nice little format. Okay, so let's take a look. This is code. We can run this. Hopefully this will give us some reasonable answers. So let's see. The first print says 3.14159. That's pretty much what we said it was going to be, right? If the area of the circle, if the circle has a radius 1, then the area is pi square units. So that's pretty much right. We put in 3.14159 for pi. The second one, a circle with radius 2, has area. Well, I said it was going to be about 12.5. Come on, go away. So it's going to be about 12.5, 12.57. So it's about 4 times, or it is 4 times that value. And then we can come through here and we can do the 75.1, and we can do it very nicely with 17,718.60 square units. So we've done our tests with the first 2 values, and now we're getting into something that's a little bit harder to check maybe. I mean, it's not all that hard with a calculator to figure that out. But now having checked on some sane cases, we can go through and be fairly confident that we've got it right. So let's look at what this actually means when we're actually running this code. And to do that, I'm going to go to our Python tutor. This is a nice little site. I think you'll like this site. It's not all that great for debugging your code or for developing your code, I guess. It's pretty good for debugging your code if you have some small issues. But the thing here is that, excuse me, been talking for a long time, is that Python tutor can show us how memory actually works in our code. So let's kind of pop our code in here, right? This is just the code we had in our spider. And let's see what actually happens when we run this. I'm going to go back all the way up to first. So first, we're just starting the program. Nothing's happening. We come in, we execute the first statement, which is this, where this little red arrow is. And you'll notice that it immediately jumps down from line 1 to line 6. But at line 1, what it's done is it's read this variable. It's read the def. It sees that we're defining a function, and it's taken, and in our global space, in our program space, it's defined our function, and it now knows how to call the function, and it knows what parameters to expect. So we can now use our function, right? So it's gone through, it hasn't actually executed any of these lines, but it has made a note of where this area of circle actually is and how to call it and what what'll need to happen when it gets called. So now we hit the next line, and this is actually the first executable line. And when we hit this line, we see the area circle with 1. In order to make this assignment to A, we have to evaluate this entire expression, and this entire expression is just a function call to our area of circle function. So it pops back up here to our definition. It sees that we have a parameter radius. It takes this argument 1 and places it into the parameter radius, makes a note of that. Radius becomes essentially a variable in our local scope for the area of circle function. We come down. The next line defines a local variable pi, and by the way, we would normally use math.pi for this. We're using pi here to demonstrate the use of local variables. So you can see that now we've defined this local variable. This is the global variable. This is the stuff that's known down here. This is known only within the scope of this function, so only within this indented area. Once we go back to the indent, we're now back in the global scope, and we're going to lose all of these local variables that we've defined. We go through, we use our local variable pi, our parameter radius, and we calculate pi times radius squared. We put that value into area, and now we hit this return statement, and the return says go back from this function to where you were called, and whatever value is being returned, essentially replace this function call with that value. So when we hit this return, we will calculate the return value. The return value is just the value of area, and now we will jump back, and we've taken that 3.14159, 3.1416, and we've stored that in a variable A that's in our global frame, in our global scope, in the scope of our main program. And now when we print out A, we print out the pi. Okay, so that's kind of the simplest case. Now let's look at the second case. We're going to hit this print statement, and the print statement, in order to complete, needs to fill in this format specifier, and to do that, it needs to calculate area of circle with value 2. So we're going to come down here, we're going to hit this line, but we can't evaluate this line until we actually know what, we can't complete the execution of this line until we actually know what the area circle with radius 2 is. So you can see that now radius, our parameter, has been replaced by the argument 2 to our area of circle call. And we're going to walk through pretty much the same. We'll define pi again. We'll calculate area using pi and our new radius of value 2. We'll do our return. This time it should be about 4 times, it should be 4 times pi, about 12.5, 12.6. We'll return that, and when we do, we push that down into this value. This is where we return to. This value of the area of circle call gets replaced with the 12.57, and then we can finish evaluating this string format command, replacing this format specifier with our 12.57 and completing the printout. Okay, one more time. We generate a radius of 75.1. We hit our area of circle call with that radius. Right now, the parameter radius has been given the argument 75.1. We walk through, we define a local variable pi, we define area. And again, notice that when we leave this function, when we hit the return and go back, we're going to go back to here. We're going to put the value that we return, the 17,718.599, into our variable A, and we're going to get rid of all this stuff for area circle. We just pop it off the stack. It's gone. We can't access it anymore. Okay, there's a return value. A now has that return value. This time when we come to our format statement, we just need the value of R and A, which we already have, and we can complete our print now. Okay, so that's just essentially a walkthrough of how Python actually goes through and executes this code. So, let's see. All right, so let's just kind of reiterate that a little bit. When we come into a sequence of code, to a code, right, when we see this function definition, we don't actually do anything. We skip down until the end of the function definition. We skip down until the place where the indentation goes back to where it was. So we have a definition of the area of circle. It has these 3 indented lines. We're done with those indented lines. We're back to here. So when we come in and execute this, right, starting from 1, right? We just completely skip over that. But what we do is the Python interpreter makes a note that a function was defined and how that function is going to be called. Right? Having done that, now we start executing code, and we kind of ignore this area circle function until we see a call to it. And when we see the call, we take whatever the argument to the call is, right? This 1 in this case. We replace the parameter or parameters with the value of the argument or arguments. In this case, there's only one argument, one parameter. So our parameter radius gets the value 1. Now we execute our function until we hit a return statement, or we run off the end of the function if this return wasn't here. Once we return back, it would be we would return. Once we no longer had anything indented to run, we would return from the function as well. But we come down here, we hit the return. We hit the return, despite the fact that there's 3 different places where area of circle is called. Here's one, and here's our current call. We always go back to the one that we were called from last, right? And then we get rid of all of the local parameters to our area call. Okay. Let's see. So if we actually look here, and if I were to actually come down here and say print pi or print area, what you'll see is that despite the fact that when we're in this circle, those values exist, down here there is no pi and there is no area. So when we hit them, right, when we hit them, they're actually an error. And they'll stop the execution of the code. All right.